Okay, so I'm going to assume the purpose of this actually lecture is to give you understanding about IP version 4 addressing and some of its features. And I'm going to assume that you don't know anything about IP addresses, okay, and we'll start from the scratch, okay? So IP address, like if I would think that, okay, you don't know anything, I would start with the example of, let's say, telephones, okay? So if you or anyone else looks at a phone number with the code, let's say 01192, okay, and then it says like 42, and then it says like 512 and 4343. Let's suppose, okay. Now in this, like because we are familiar with the telephone numbering systems, you can easily identify that, okay, these numbers, they identify as a country code, okay? So this is for code for Pakistan, okay? Now, if you are dialing in Pakistan, in normal, you would know that 42 is the code for the city, which is Lahore, okay? So this is for Lahore. And once it goes in Lahore, then there will be multiple local telephone exchanges, and this is the number that identifies end of the phone or end user's basically device in his home, correct? Okay. So there is a basically hierarchy. When in older times you would actually dial the numbers with the digital phone or whatever, right? So all of these numbers go into the local exchange, and the local exchange system will see that, okay, this code, that means I need to actually route this call to the Pakistan. Okay, then whatever satellite system they used to have or fiber system or whatever, when it hit, usually it would hit Karachi because that's the main hub. Okay, in the Karachi telephone exchange systems, when they see that, okay, so next code is 42, so they will route it to Lahore, and then within the Lahore system there will be a hub that will actually see, okay, what exchange it will go to and what is the end number. Okay, so what we are actually doing, we are segregating numbers to identify country, city, and subsections. Okay, we are identifying actually the home phone number or the end device. Okay, and there is a hierarchy into it. IP addressing concept is exactly same. Okay, but because it is in the computer system, they said, okay, IP addresses. So basically, IP address is like a phone number to identify a device on the network. Okay, so that means two devices on one network cannot have same IP address. That makes sense, right? In one network, okay, two devices, they cannot have the same name. Now, when I say that in one network, two devices cannot have the same name, that means there will be a mechanism to identify the network address as well. In one IP address, what is the network address? What is the host address? Because two hosts cannot have the same address in one network. Like in one exchange, two end users cannot have the same number. Correct? Okay. So with the IP version 4, the address length was decided when whosoever actually started with this IP addressing. It's a 32-bit address. Why? Because it's a computer. So for the computer, IP address is a just string of 32 bits. Okay. So 32 bits means 1, 2, 3, 4, 5, 6, 7, 8. Okay. And another 8 bits, and another 8 bits, and another 8 bits. Okay. Now, bit is one number, either 1 or 0. So if you are are you familiar with the binary system? Okay, so are you familiar with the binary system? Okay, I will give you the example. Okay, you are familiar with the decimal system, right? So we start from 0, we go to 9, and we say, okay, now next one is 10. So the base is 10. In the binary, base is 2. And I will give you the example how to change from decimal to binary and binary to decimal. So these bits, 32-bit is the length of the IP version 4. Now, okay, there are two versions. in the start, there was IP version 4. Now they have come up with IP version 6. We will focus on IP version 4. Okay, so IP version 4 addresses are maximum 32 bits long. Okay, so in the computer perspective, 32 bits is just a stream of bits. Now for our understanding, we will actually change it into the 8 bits format, and we will put a dot into it so that we can actually remember it. Let's say 192.168.10.10. Okay, so for us it is 192.168.10.10. For computer, it's a basically 32 bits long string of characters, either zeros or ones. Okay, so this is the decimal format for our understanding. For the computer, it's basically exactly 32 bits long string of bits, either it's a 1 or 0. Okay, so now I'm going to give you the example how to change from a decimal to binary and binary to decimal, and I'll go a little bit more details before we go into the detail how IP version 4 has been classified into different classes. Okay. So if I take one decimal number, let's suppose 17, and I want to actually change it into binary, I will just divide it by 2. Why? Because the base is 2. We want to change it from decimal to binary. So I will say 2 multiplied by 8 is 16, and what is left is 1, right? So 2 multiplied by 4 is 8, and what is remainder? 0. 2 multiplied by 2 is 4 and 0, okay, and 2, 1 and 0, and I will write down like this. So I'll say 17 in binary is 1 0 0 0 1. Okay, and if 17 is this in the binary and I want to change it into decimal, we will say that 1 here, the value is 2 raised to power 0 multiplied by 1. So this is the one, okay, plus 2 raised to power 1, because we will increase the base values power by 1 each time. Okay, so 2 raised to power 0 multiplied by whatever bit we have, plus 2 raised to power 1 multiplied by 0, plus 2 raised to power 1 multiplied by 0. So we have 2 zeros, and I'm going to say 2 raised to power, here it shall be 2 raised to power 3 multiplied by 0. So 1 2 3 1 2 3 plus 2 raised to power 4 multiplied by 1. Okay, so when we change it into I multiply, so this is actually 2 raised to power 0 is 1. Okay, 1 plus 0 plus 0 plus 0 plus 2 raised to power 4 is 16. Okay, 16 plus 1 is 17. Okay, so the position of these bits actually tells you what will be the weight of this bit. Okay, so if I write down 8 bits, 1 2 3 4 5 6 7 8. Okay, so 64 and 128, right? So 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and so on. So the 8 bits will carry the weight. The first bit is 1, second is 2, 4, 8, 16, 32, 64, and 128. Okay, so whenever we are going to change our IP address, which is a stream of 32 bits, we are going to actually change it into 4 octets. Octet means 8 bits, right? So if I say 192, that means I'm going to change it into 8 bits. If I say 168, that will be 8 bits, okay? So if it is, let's say 9 is here and 17 is here, okay? So I'm going to say, if it is 17, I'm going to say 1 0001, okay, and how many bits are these? 1, 2, 3, 4, 5. Last 3 bits I'm going to add as 0, and this is 17 actually in decimal, okay. See, like when I changed 17 into binary, it was 10001. So I wrote 10001. Now on the left hand side I will add zeros. Why? Because if I will add zeros here, the weight will change. I want to have the first bit which with the weight actually 2 raised to power 0 as the first bit, and second, third, fourth and fifth bit as 2 raised to power 4, okay, and the rest 3 I will add zeros, and this will actually show me that this is how computer will see 17. Not really 17, what I mean actually 9, whatever bits are there, 168, whatever bits are there, 192, whatever bits are there, ones and zeros. So this is how computer looks at it as an IP address. Okay, so I've given you the example how to change from decimal to binary and binary to decimal. Okay, and as I said that IP version 4 address is 32 bits long. Now, how they have actually decided, or how it was decided that from these 32 bits, what portion is the actually network portion and what portion is the host portion, I'm going to go into its detail, okay? The rule on based of which they have decided or categorized these addresses into different classes, they call it first octet rule, okay? And first octet rule says you take leftmost 8 bits. From the string of 32 bits, we will take leftmost 8 bits, and then there is a first octet rule on based of which we will say that, okay, these from this range to this range, the addresses will be in A class. From this range to this range will be B class and onwards. And what is first octet rule? I'm going to actually explain. First octet rule says that if you are taking the leftmost 8 bits, take first bit as 0 as constant, okay? And the last 7 bits, 1, 2, 3, 4, 5, 6, 7, they are variables, okay? Okay, so if you remember that the weight of this bit is 128. So if you have all ones, 1, 2, 3, 4, 1, 2, 3, 4, and if you change it into binary, it will be 255, okay? It's basically how many possible combinations can be there? 2 raised to power 8, right? Why? Because there are 8 bits, there are 2 raised to power 8 possible combinations that we can get it. Now, if you change 2 raised to power 8 is equal to 256 possible combinations. But if you will add up in the decimal, it comes to 255. Why? Because the possible combinations are from 0 to 255. Okay, so from 1 to 255 plus 0 combination. Okay, so 256 possible combinations are there, right? And the weight of these bits are 1, 2, 4, 8, 16, 32, 64, and 128. So first octet rule says that take first leftmost bit from the 32 bits as 0. Okay, from the left octet, leftmost 8 bits as 0, and you can actually vary the numbers in these 7 bits, and that will give you from 0 to 127. So 2 raised to power 7 will give you 128. So and the possible numbers will be 0 to 127. Okay, 127 is reserved, so they say, okay, from 0 to 126 is a class address. Okay, so based on this rule, actually they are categorizing addresses into different classes. A class is from 0 to 126. For B, take first bit as 1, the second one as 0, constant, and you will keep this as constant, and the 1, 2, 3, 4, 5, 6 bits are variable. So that will give you from, and this is 128 now, right? We know that. From 128 to, this will be 31. So 128 plus 1, 2, 4, 8, 16, and 32. So this will be actually 63. Okay, so if you will add up, this will be 63. 8 plus 3, 1, okay, and so it will be 191. Okay, so this is B class. So for C class, take left two most bits as ones and the third one as 0, and you can actually vary 5 bits, and this will give you 128 plus 64, 192, and it goes up to 223. Okay, so 192 plus 31, yeah, 223. Okay, so it goes up to 223. Okay, so this is C class address. Now,
so in class A, where did 127 go?
127 is reserved for the testing purpose, for the local testing. Okay, actually, to 223 is C class address. Okay. Now it was decided. Now how computer would actually recognize that even. Let's suppose that I want to take like 11.12.13.14 as an address. So how computers would know that which portion from this address is network address and which portion actually is the host portion? Okay, so they come up with the idea of subnet mask. So under this address, wherever you will have ones only, that will be actually the network portion, and wherever you will have zeros in the subnet mask, that will be the host portion. So for A class, they decided that by default, we will take 255.0.0.0. So this will be the default subnet mask for all the addresses under A class. Okay, that means from 0 to 126 is A class. So from this number, I know that this address belongs to A class, and by default, if I am not given that what is the subnet mask for this address, I would say okay, 255.0.0.0 is the subnet mask. Okay, now 255 when you change into binary, it's all ones. So that means all ones under 11 is indicating that this is the network portion, and these 24 bits are the host address. Okay, so from here I can see that A class addresses would usually be used for very big networks where you have too many hosts. Why? Because you can have 2 raised to power 24 number of possible combinations of host addresses under one A class address, right? Because why? Now this is another important concept. In one network, your network address will stay the same. I will repeat. In one network, because you are talking about one network, so all the bits under these 8 bits will stay same. If I make any change and make it 12, that means I'm actually going from one network to another network. But under one network, host bits will be variable. So you can change, and every change will identify another host. Correct? Okay. So for B class, they it was agreed that 255.255.0.0 will be the default subnet mask. For C class, 255.255.0 was decided as default subnet mask for C class, okay? So for D class, 1, 2, 3 bits are reserved as constant as ones, and then 4 bits will be variable, okay? So that will go from 224 to 224 plus 1, 2, 4, 8, that will be 15, 224 plus 15, 239, okay? So this is reserved, this is D class address, this is reserved for multicasting. So in normal, you won't see addresses assigned to the end hosts from this range. So this is for multicasting, okay? We will go further. So for E class, 1, 2, 3, 4, 5 bits are reserved as 4 ones and 1 0. And the 3 bits are variable, so this will give you from 240 to 255, and this is E class, and this is reserved for research purposes. Okay. This is how they have classified IPv4 into A, B, C, D, and E classes or categories. Okay. And these are the default subnet mask for A, B, and C class, and with the help of subnet mask, computers, they identify that from this or any address, what portion is the network portion and what portion is the host portion. Okay. So if you are clear on this, we will actually move on to subnetting. Okay, so we'll take what is subnetting actually. That let's suppose that you have been assigned one network address and you want to break it down further into smaller networks. Okay, so that is actually subnetting. If you have multiple networks and you want to squeeze it into one, that is called supernetting or route summarization. So I will give you one example how we actually take one network address and break it down into further subnets, and then we will talk about, there is a concept of variable length subnet masking. I will give you the example for that, and then at the end we'll talk about supernetting, which means actually that you take 4 or 5 multiple addresses and you squeeze them into one. Like, you know, subnetting is taking one address and breaking it down into further smaller networks. Supernetting or route summarization is that you take 4 or 5 addresses and you merge them to one. Okay, and I will give you the reason as well in what situations or what circumstances both are beneficial. Okay. Okay, if I take the example of 172.16.0.0, so this is a B class address. For B class address, the default subnet mask is 255.255.0.0. So how many bits are 1 in this subnet mask? 16, right? 8 plus 8. So the same subnet mask I can write down as /16 as well. So this basically tells me that 172.16.0.0/16 means 16 bits are the network portion, and the rest of the bits from these 32 bits is the host portion. Okay. So this is one network address, okay? Now, why we usually need to break one network into multiple subnets? In the networking world, okay, if you have a big network, okay, all these devices which are having the IP addresses from one network address, they can be connected to switches, and switches, they are connected to each other, okay? So I will not go into the detail because Imtiaz will actually explain to you this, but one of the problem in this is because we are actually using one big network and we are putting all the devices with their IP addresses in the same network. If this is actually a broadcast domain. Broadcast domain means that if this computer connecting here, its network card starts malfunctioning and it starts sending all the broadcasts, lots of broadcasts. These broadcast packets or frames on your network, they are actually copied on all ports. This is the default behavior of the switches. Switches are the devices where you hook up your cable and your computer has IP address. So the default behavior of the switch is that if it will receive a broadcast frame, it will copy onto all ports. That means every port will receive it. Now what in turn I'm saying, that if one device is having problem and it starts sending like, let's say, millions of broadcast frames per second, it can bring down whole of your network. To remedy this, we break down one network into multiple networks. Why? Because it's a requirement in the networks that if you have network 1 and network 2, means they are having different network addresses. If you want them to talk to each other, you need to place a router in the middle. So network 1 and network 2 will actually communicate through the router, and a router's default behavior is that it's going to filter out the broadcasts. So this is the benefit, one of the benefits, that you break down one network into multiple networks. If one side is having problem, this other side is protected. Okay, so this is one of the reasons that there will be a routing device, and another benefit is that on the router there is something called access control list. We can control who can go from network 1 to network 2 on what port. So a lot of actually control we can implement in the routers, which is not available in the switches. So this is another reason why we actually break down one network into multiple networks, right? Because it's a requirement. One network cannot talk to the other network unless it passes through the router. And on the router, routers by default will filter out the broadcast. So that means if you are having problems on this side, because of the broadcast storm, it won't impact on this side. Similarly, we can have control, more control using ACLs and stuff like that, okay, on the router. Okay? So these are a couple of reasons why we want to break down one big network into multiple smaller subnets. Okay? All right. So what's the time? What's the time?
4:20.
Huh?
4:20.
4:20. Okay. So how do we divide it? I'm going to actually go into its detail. Okay. So what I said, in one network portion stays constant. And you understand it, because in the network portion, if we make any change, we are jumping from one network to the other. Host portion actually varies, okay? So if, that means if I have been given 172.16.0.0/16 and I want to break it down into further subnets, I cannot make any change in this portion. Why? Because it is given to me. I can play around with the 16 bits which are variable for me, okay? Because I have been assigned 172.16.0.0 with this /16. That means for me, these 16 bits are constant. This was the network address given to me. I want to break down this network into further subnets. That means I can actually play around with this. Now, let's suppose the requirement says, where is my cheat sheet? So let me actually bring it because I don't want to waste time. It will be easier, quicker. don't know where did I put it. Okay, no problem, we'll start. Okay. All right. So let's suppose the requirement says that we want to have 1200 subnets with 60 hosts on each subnet. Okay. So I'm just giving the requirement. Requirement says that this one network we want to divide it into 1200 subnets with 60 hosts on each subnet. And how we want to break this network down into further subnets, we will move the bits from our host portion into the network portion. Okay, we will actually decide that, okay, from now on, these many bits we will consider as network bits. Okay, so 172.16 is constant for me. Okay, and 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. 16 bits are variable for me. Now, how many bits I will move, which will give me 1200 possible combinations? These 8 bits will give me 256. Okay. If I move another bit, 256 multiplied by 2, 512. 512 multiplied by 2, 1024. Still, my requirement is not met. 12, so that means 12, 10, 24, I need to move another bit. Okay, so I need to move to meet this requirement 8 plus 3, 11 bits into the network portion. Okay, how many bits are now left with me as a host? 5. 2 raised to power 5 is what? 32. Okay, so I chose this example intentionally to show you that you cannot always fulfill any requirement. Okay, so that means someone may actually tell you that, okay, take this and break this down with 1200 subnets with 60 hosts on each. You cannot do that. Why? Because if you are meeting this requirement, you are moving 11 bits and you have only 5 bits left in the host portion, which cannot give you more than 32 addresses. Okay, so that means your requirement should actually be given by someone who knows the stuff, right? Okay, so let's make it reasonable, and I can actually change it as it is. I will say, okay, if we have, let's say 1000, okay, with 60 hosts, that means if I move 10 bits into the network portion and 6 bits are left in the host portion, these are the 6 bits, so that will meet the requirement. 10 bits will give me 1024 subnets, 6 bits will give me 64, okay, so that meets the requirement. I'm going to erase it so that we can actually start from the clean, okay. Okay. So the requirement was to break this further down into 1000 networks with 60 hosts on each network. Okay? So what I did, the first step is we decided that how many bits we want to move from our host portion into the network portion that will actually meet the requirement. Okay? So 172.16.1234567 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if I move 10 bits, okay, into the host portion, into the new network portion, that will meet the requirement. If you have any questions, issues so far, let me know. Okay, so based on our requirement, we agreed that we will move 10 bits into the network portion. This portion we cannot change because this was given to us. Okay. Now this is our network portion. Okay. This is our new network portion. Okay. Because we agreed or decided to move 10 bits into the network portion, and this is our host portion. Okay. And we know that how computers identify that what is the network portion, we put all ones under it. Okay, so that means here it will be 255.255, and if I put all ones here, that will be 255, and I will put 1, and in the subnet mask we put zeros in the host portion. Correct? So 1, 2, 3, 4, 5, 6. So the new subnet mask will be 255.255.255.128 plus 64. This is 128, wait, 64, 192. If I'm mistaken, let me know. 128 plus 64 is 192. So this is the new subnet mask. And if we change it into like numbers, 24 bits plus 2, 26. So 26. Now, very important concept, okay? That we will now calculate how many 1024 subnets, and we will calculate by playing around with these 10 bits. Okay? But subnet mask will stay the same, /26. Why? Because as far as we are making any change here, computers, they would know that this is the network portion, okay, and they will know that network address has been changed. So for the computers to know that the network address has changed, you don't need to change the subnet mask, because in the network portion, this is the network portion that we agreed, we decided to move into the network side. So we will play around with these bits in this portion, new network portion, to calculate first subnet, second subnet onwards. Okay? But the subnet mask will not change. It will stay the same, /26, because 26 bits are the net used to identify the network address, and the 6 bits are the host portion. And in each subnet, we will calculate what is the first valid IP address, what is the last valid IP address, what is network address, and what is the broadcast address, and I will actually show you it. Okay? So, to calculate the first network address, because we already have agreed that, okay, these 10 bits in our network portion, okay, where we can play around. So I will say, okay, let's take all bits as 0 as the first network address. That means I can say that my first network address is 172.16.0.0/26. Another very important point, that when you look at 172.16.0.0/16 and 172.16.0.0/26, they are not same networks. They are different network addresses. Why? Because you can see now from here. Here up to this portion is the network address. Under 26, you have up to this portion is the network address, and they are different, they are not same. Okay? So this is first network address that we have derived from our subnetting. Okay? Now, I'm going to write down into bits this portion 172.16.1234567 1234567. Okay? So this is the network address. Okay? This is the host portion. Right? Now, network address usually is identified when we put all zeros in the host portion. This is my network address. What will be the first valid IP address? Everything same in the host portion, all zeros, last one is our first valid IP address. Last valid IP address will be all ones, last 10 is the last valid IP address under this subnet. Now when I'm making the calculations under this subnet, I'm not going to make any change in this portion, because if I will make any change in this portion, I will jump into the next subnet. And broadcast address is, and the rule is that you will put in the host portion all ones, and that will give you the broadcast address for that particular subnet. Okay, so now if I change this into binary, my subnet address is 172.16.0.0. My first valid IP address is 172.16.0.1. Okay, when we will change this into decimal, we will actually bracket these 8 bits. Not 8 and 2, no. We will change it into decimal, we'll change them 8, 8, 8, 8. Okay? So I have changed this, and I have changed this as well. Okay? 0, 0, 0, 0. Okay? Why? Because I'm not making any change in this portion, because this is my network portion. Okay? But when we are changing into decimal, we will bracket them into 8. So 172.16.0. What is this? 2 raised to power 6 is what? 1, 2, 4, 8, 16, 32. Okay, so this will be 62. And all ones will give you 0.63. Okay? So this is my subnet address. This is first valid IP address in this subnet. This is last valid IP address in this subnet. And this is the broadcast address for this subnet. Okay? I'm going to calculate second subnet. Okay?
So 172.16.0.0, isn't it called network?
Network address. This is the network address, yes. Okay? So I'm going to calculate second subnet now. Okay? So I'll say 172.16.1234567 and these 2 bits are my network portion as well. I'm going to make one change. From 0, 0 I change to 0, 1. Okay? And for the network address, we put zeros in the host portion. Okay? This is my second subnet address. What is it? 172.16.0.1248163264. So this weight for this bit is 64. So 0.64 is next subnet address. Okay? I'm going to calculate now first valid IP address, last valid IP address, and the subnet mask under this subnet. So when I will be making these, I will not make any change in this portion. It will be staying as constant. Okay? So all zeros, last one is first valid IP. All ones, 1, 2, 3, 4, 5. Last 0 is the last valid IP address. And all ones is 1, 2, 3, 4, 5, 6 is the broadcast address for this subnet. So if we change it into decimal, it will be 172.16.0.0. 0.65 now, right? Because 64 plus 1, okay? And 17, what will be the last valid IP address? 172.16.0 dot, this is 1, 2, 4, 8, 16, 32. So 32, so I will be adding actually 62 into it. 65 plus 62,
127.
be 126. Okay, so 172.16.0.127 will be the broadcast address for this subnet. I'm going to calculate. Okay. Are we doing any mistake here? Let me see. So it's 5 bits, last one 0 will give us, all ones will give us 63, 62. Shouldn't be really like, okay, 64 plus 62 is actually, so I should be adding actually 126, which is correct, okay? So the calculation is correct there, okay? So I'm going to calculate now the third subnet address. So 172.16.1234567 and I'm going to make a change now here, 1 0. Okay, so I have changed 1 bit and I've changed this back to 0 just to keep things in sequence. Okay, so 1 2 3 4 5 6. Okay, so this is my third subnet address. So subnet address will be 172.16.0. This is 128. Okay. So first valid IP address will be all zeros, last one 1, and all ones, last one 0 is the last valid IP address, and all ones is the broadcast address. Okay. So 128 plus 62 will be the last valid IP address. Okay, so 172.16.0.129 is first valid IP address. Okay, 190 is last valid IP address, and 172.16.0.191 is the broadcast address for this subnet. Okay. So now, if you look at, there is a now sequence in the things, okay? So if you look at this, subnet addresses, okay? First subnet address was 172.16.0.0, second was 0.64, third was 0.128, okay? So how much it is actually jumping, changing from one subnet address to the second one? 64, right? From 0 to 64 to 128. Okay? It's changing from one subnet address to the next subnet address by 64. How many bits we have in the host portion? 6. 2 raised to power 6 is what? 64. Now remember this. I even forgot it once, okay? Because I stopped teaching and that's it. So subnet addresses will jump 2 raised to, at the rate of 2 raised to the number of bits in the host portion. Okay, I'll repeat. So subnet addresses, they will jump starting from 0, like this is 0.0, at the rate of 2 raised to the number of bits in the host portion. Okay, so that means I don't need to now go all through this. Okay, I will add 64 into it, and I will get the next subnet address. Okay, so let me actually put it here and I will show you like some more tricks here. Okay. It is dry. Okay. So what will be my next subnet address in that case? 172.16.0.128 plus 64 will be 192. Okay, will be my next subnet address. So 192 plus 64 becomes 256.
Yes.
Okay, so that means we'll have basically all ones here. Okay, so we don't want to do that. So what we'll do, we'll make one change here. Okay, so 172.16.1 dot. Okay, because all ones will actually give you the broadcast address for this. Let me actually calculate it. Okay, so for 192, what will be the first IP address? First IP address is always your subnet address plus 1. Okay, 193 is my first valid IP. What will be my last valid IP? Usually we added 192 plus 62. Okay, 254 is my last valid IP address. So all ones, 255 is my broadcast address for this subnet. So from 255 we cannot go further. Okay, so that means I will move now one bit. I have actually, how many possible combinations I could have here by changing 2 bits? 4 addresses. I already have it. 1, 2, 3 and 192, 4. So that means these possible combinations are already covered. Now I will change 1 bit here, and with this 1 bit I will have 4 more. Okay, so that means next subnet address will be 172.16.1.0. I will say 00. And what will be the first valid IP address in this? Will be 1, will be the first valid IP address. 62 will be the last valid IP address. 63 will be the broadcast. And 172.16.1.64 will be the next subnet address. Okay? Because now I'm just keeping this as 1 and I'm changing these 4 again. Okay? 64, 65 is first valid IP address. 126 is the last valid IP address. 127 is the broadcast address for this subnet. I will keep this as it is. 172.16.1.128 is my network. See? So the rule is that subnet addresses jump at the rate of 2 raised to power number of bits in the host portion. Okay, and you can calculate. And first valid IP address will always be the subnet address plus 1. Okay, last valid IP address will be 1 less than the broadcast address, and the next subnet address will be 1 you add into the broadcast address of your previous subnet and you get the next subnet address. Okay, so this is actually subnetting, where we took one network address and we broke down further into multiple subnets. Now we have so many subnets. Let's suppose their new requirement came in and they said, okay, we want to have further networks with /30 addresses, like where we have only 2 valid IP addresses. Okay, so what I can do, I can actually take one of the addresses from this. Okay, so let me erase this one. So the requirement is that, you know, like we have point-to-point links where we need just 2 valid IP addresses. Okay, so I don't want to waste, means I can use one of these network addresses as well, but I need just 2 valid IP addresses. Here we have 62 valid IP addresses. So I can take one of this network and break it down into further. Okay, so if let's suppose that if I take this one, okay, so I will take 172.16.0.64 as my network address, which is /26. Okay, and I break it down into further. Okay, so if I want just 2 valid IP addresses, means I need just 2 bits in the host portion. Okay, if I want to have 2 valid IP addresses, I just need 2 bits in the host portion. Okay, here how many bits we have in the host portion? 26 is the network portion. 32 minus 26. Okay, 26 plus 4. So that means I can move 172.16.0.1, 2, 3, 4, 5, 6, 7, 8 Okay, so I can move these 4 bits now. So this was, okay, this was the network address given to me up to this portion, and I moved this as new network. Okay, this is my host portion now. Okay, so now how many bits I have in the network portion now? 30. 26 plus 4. So I have 30 bits in the network portion. How I will calculate subnets within this? Subnet addresses jump starting from 0 subnet 2 raised to power number of bits in the host portion. That means 172.16.0. Now I'm not going to, I cannot make any changes here in this portion because this was given to me. Up to this bit 64, I cannot make any change. 64 as it is /30 is my first subnet. Next one will be 2 raised to power 2 is what? 4. So subnet addresses will jump at the rate of, if 64 is first, 2 raised to the number of bits in the host portion. So next address will be 172.16.0.68/30. Okay? If 64 is my subnet address, 65 is the first valid IP. 1 less than the next subnet address is my broadcast address, and 66 is my last valid IP address in this. And you can keep on. Now, this concept that you took one subnet address, you broke down into many subnets, and from those subnets you picked up one and you broke it down into further, this is called variable length subnet masking. Okay? Why? Because you have now same address from the main parent address with different lengths of subnet masks. Here you have 26, here you have 30. Okay? So this concept is actually called variable length subnet masking, where you take one parent subnet, you break it down into many subnets, you take one subnet from those subnets and you break it down further. So this is variable length subnet masking. Okay? So if this is good and easy, I'm going to actually give you the concept of route summarization, or they call it supernetting. In this portion, what we did actually, we took one subnet address and we broke it down into smaller networks. What happened? Number of bits in the network portion increased. So inverse, we will take multiple network addresses, we will squeeze them into one network address, number of bits will decrease. Here it increased. You can see that. Okay? So we took one network address where we have lots of hosts. Okay? We broke it down into multiple subnets, and number of bits in the network portion increased. Okay? So supernetting is actually inverse of this. We take multiple subnets and we squeeze them into one. And I'm going to give you the example on the board, okay, for that. And I'll give you the basically reason why we do that. Okay? So we are recording it. We'll give you the video as well so that you can actually listen it again. Okay? And he has the software. He can actually cut it down. He can cut down my belly as well on the recording. You know, teaching is a skill. I had one teacher at FAST in Lahore, and we had a problem with one of the teachers in the college, and he was teaching physics. He was an atheist, so he would actually try to mess up with the students' brains, and usually people are young. So in the Prophet's life, there are miracles, right? So In one of the miracle, Prophet Muhammad, peace be upon him, actually he drank from one bowl of milk, and he had, like, let's say for example 50 followers sitting there, and he said, okay, now you can drink, everybody. And everybody drank, they were full from the one bowl, and at the end he drank and he finished it. So this was a miracle. This is not normal stuff. Means I can't do that. Right? So he would actually question students in his class that how come a person can actually nonsense, stupid person. Right? So I heard this once and I was so upset on that. I said, if you are messed up, keep it to yourself. Right? So I spoke to one of the teachers and I said to him, like, sir, we need to talk to the director. Like, he shouldn't really be talking this type of stuff with the students. And he was so actually, like, interesting personality. He said, what? He's saying this? And he was electrical engineer, Bilal Hashmi sir. So Bilal sir said, I'm going to talk to Dr. Khawarzia. If he cannot find any teacher in physics, I'm going to go and teach myself. And he said it, and that's what actually the point of sharing with you. He said, teaching is a skill. He said, you give me anything and I will teach you. Why? Because basically, if you have a skill to explain, you just learn whatever it is and you explain it nicely. That's it, people will understand. We had a teacher here, like, he is excellent in professionally, and his material is really good as well. But, like, in explaining is so bad. We have tried him twice in Azure bootcamp, and, like, half of the class would leave. We don't sit here. So we have to now say sorry to him, and, like, we are actually bringing in another person who is Microsoft trainer for years, and he will be the one who will be delivering Azure training from now onwards. Okay, so for Supernetting, okay, we understand now why we actually want to break one network. I gave you the reason. It will limit the broadcast domain. One network, if he has to go to the second network, it has to go through the router, and on router we can control using access control lists. So there are some scenarios where we want to actually squeeze networks into one, and I will give you the example of that. For example, if you have a router here, okay, and router has 4 network addresses. 172.16.0.0/24. Okay, now /24, so far you should be able to understand that up to 24 bits is the network portion. The last 8 bits are the host portion. So second subnet is 172.16.1.0/24. Third one is 172.16.2.0/24. And the fourth one is 172.16.3.0/24. So they are, all 4 are different network addresses. Why? Because in the network portion we see the changes. Okay? In the 24 bits, they are changing from one network to the other. Now, if this router is using a routing protocol and is sending information about these networks to its neighbor, okay, because this is router's job. Okay, if I'm a router 1 and there is a router 2 I'm talking to, and if I want to tell router 2 that, okay, I know how to reach to these networks, I will send information about these networks to router 2. I will tell him that 172.16.1, 0, 1, 2, 3, all of these networks, if you receive a packet for that, send it to me. Because I know how to reach, they are directly connected to me. Okay? So basically that means if router 2 would receive a packet for 172.16.2.10, for example. So router 1 knows that this subnet, router 1 knows how to reach. Because router 1 has already informed me. Okay? So he will send the packet to router 1, router will send to the host through this. So this is routing as well. Okay? Now in normal, router 1 would send 4 entries to router 2. And router 2 will have it into its routing table that to reach 172.16.0.0, 172.16.1.0, 2.0 and 3.0, okay, /24. I need to send the packets to router 1. So these 4 entries will be in the routing table of router 2. Okay. Now, if I can squeeze these 4 entries into 1, that will save the space in the routing table and it will be more efficient. Okay. So what I can do, as a router 1, when I'm sending the information to router 2, what I'm actually practically telling? I'm telling router 2 that 172.16.1, because of the 24, means up to 24 bits, if you match, doesn't matter what is there, you send it to me. Correct? Isn't it? This is what I'm actually saying to router 2. That as far as 24 bits match, because they are constant, they are one network. For the variable bits, we are putting 0, and we are telling the neighbor that don't care about the variable bits. Whatever it is there, as far as your constant bits, which is the network portion, matches, send it to me. Now, if I look at these 0, 1, 2, 172.16 is anyways constant. Okay. So from these 8 bits, let me see if I can find more constant bits. Okay. So I'm going to 1, 2, 3, 4, 5, 6, 7, 8. So this is the third octet. Okay. So this is in decimal. The second one is 1, 2, 3, 4, 5, 6, 7, 8. This is 1. The third one is 1, 2, 3, 4, 5, 6, 1, 0. So this is 2. Correct? So 1, 2, 3, 4, 5, 6, 1, 1. So this is 3. Okay? Now if you see this combination, so this is 0.0. Okay? This is 1.0, this is 2.0, and this is 3.0. But these are /24. Okay. So if I'm router 1, see, if I squeeze from 24 to 22, and in the variable bits I put here all zeros. Okay. I can send one entry to my neighbor that 172.16.12345 bits, they are common in all 4, and these 2 variables, I know all the variables, they are on my side. So I can say 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8, and I can squeeze it from 24 to 22. So rather than sending 4 entries, I can send to the neighbor 172.16.0. Why? Because I'm putting now zeros here, because they are variables. And what we do in the variables, we put zeros. And where we put zeros in the variables, where we can actually manage to send traffic to all possible destinations. So if I'm actually squeezing these 2 bits, I have all the possible combinations on my side. So I will put zeros here and I will squeeze to 22. I will send one entry to the neighbor. Why? Because 22 means 23rd and 24th bit doesn't matter. If it would be 0, 1, 2 or 3, I'm telling router to send it to me. I have all the networks on my side. So I squeezed 4 network addresses into one network. In subnetting, number of bits increased. Here, number of bits decreased. This is Supernetting. Okay? Or they call it route summarization. Why? Because we summarized 4 routes into one route and sent it to the neighbor. Practically what we are doing, we are sending the common bits up to 22 common bits, and for the rest everything we have it on our side. Why? Because router 2, if your router 2 sends me, let's suppose, one packet with the destination 172.16.3.55. Okay, I will have it. It sends me 2.69. I have it. Basically, in these bits, after 22 bits, last 2 bits in the third octet, and all 8 bits in the last octet. Whatever variable is there, I'm telling router to send it to me, okay? I can manage it. So rather than having 4 entries in the routing table of router 2 will have 1 entry, and this is route summarization, or they call it supernetting also. Okay, you squeeze networks into one network. Okay, so this is, we have discussed today what IP version 4 address is, on what rule, first octet rule that we discussed, on based of which IP version 4 has been categorized into A, B, C, D, and E classes. What are their default subnet masks? What is subnetting? We took actually one example, we broke it down into further subnets. We took one subnet from the broken subnets and we broke it down further. This is variable length subnet masking, and we talked about route summarization or supernetting as well. Okay, so these are actually extremely important topics in networking, no matter what you do. Basically, you go to the AWS, you go to Azure, you do CCNA, you do VMware, doesn't matter really. If you understand this, life will be easy for you. Otherwise, you'll keep on struggling. Okay? Right? So if you have any questions, let me